Above is a class of 100 students. If 70% of the students in the class are female students, could you tell me how many female students in the class?
Hey, I'm Teacher Tang. If you like my videos, do remember to subscribe my channel so that you won't miss any notifications when I update my channel. Today, I will share step by step on how to determine empirical formula if you are being given mass percent of each element present in the compound. So how to do that? We are going to use the mathematical concept on percentage.
How about if you have been given mass percent for each of the elements present in a compound? How do you determine the empirical formula? So basically, if you have been given mass percent compositions of each of the elements, you just need to add 2 more steps. So before going through the 4 steps, you need to add 2 more steps. So step number 1, you need to assume the sample is 100 grams, and in step number 2, you need to calculate the mass of each element first. Then only you construct the table with rows to fill in element mass, moles, mole ratio, and empirical formula. Then step number 4, you calculate moles of each element, and step number 5, calculate mole ratio. And in step number 6, only you write down the empirical formula. In these examples, we have been given the mass percent of each element present in ascorbic acid. Carbon 40.92%, hydrogen 4.58%, and oxygen 54.5%. And we are being asked to determine what is the empirical formula and molecular formula of ascorbic acid, given the molar mass of ascorbic acid is 176 grams per mole. So to determine the empirical formula, we just need to follow through the 6 steps. So step number 1, we need to assume our sample here ascorbic acid, the total mass is 100 grams. Step number 2, we calculate the mass for each of the elements present in the ascorbic acid. So given in the question, in the ascorbic acid consists of what elements? Consists of carbon, hydrogen, and oxygen. And the mass of each element are given in percent. So remember, mathematically, percent means per 100. Hence, in step number 2, when we calculate the mass of each element, for example, carbon, 40.92%, so 40.92 over 100, multiply with total mass of ascorbic acid, which we assume in step 1 equals to 100 grams. And the 40.92 grams that we get is the mass of carbon. We do the same thing for mass of hydrogen. So 4.58%, so means that 4.58 over 100 multiplied by total mass of ascorbic acid, 100 grams, and we get 4.58 grams as the mass of hydrogen. For the mass of oxygen, 54.5%, so 54.5 over 100 multiplied with total mass of ascorbic acid, 100 grams, so we get 54.5 grams mass of oxygen. Step number 3, we construct a table with element, mass of element, moles, mole ratio, and empirical formula rows. In step number 2, we already found the mass of each element, so we just put them in. And in step number 4, we calculate the moles for each of the elements. So we have mass, how to calculate moles? Again, the formula, mass divided by molar mass. So for carbon, the molar mass is 12 grams per mole. So to find the moles of carbon, 40.92 grams divided by 12 grams per mole to give us 3.41 moles of carbon. How to find the moles of hydrogen? Again, mass divided by molar mass. And the molar mass of hydrogen atom is 1 gram per mole. So mass 4.58 divided with 1 gram per mole to give us 4.58 moles of hydrogen. To find moles of oxygen, 54.5 divided by 16 gram per mole because the molar mass of oxygen's atom 16 gram per mole, so giving us 3.41 mole. In step number 5, we calculate mole ratio. So how to calculate mole ratio? In step number 4, we already found the moles, and the smallest moles is 3.41. So to calculate mole ratio, we divide all the moles with the smallest mole we calculated in step number 4. So to calculate mole ratio for carbon, 3.41 divide with 3.41, the smallest mole, we get 1. So to calculate mole ratio for hydrogen, apply the same thing. 4.58 divide with the smallest mole, 3.41, we get 1.34. To calculate mole ratio for oxygen, do the same thing. 3.41 divide with the smallest mole ratio, 3.41, and we get 1. So in step number 5, we want to get simplest whole number ratio. But here we get 1 for carbon, 1.34 for hydrogen, and 1 for oxygen. Can you see that 1.34 is not a whole number? So how to make it whole number? So the easiest is to multiply 1.34 with 3. Then we get approximately equals to 4. So we can assume the whole number is 4. When we multiply 1.34 mole ratio of hydrogen with 3, we also need to multiply the mole ratio of carbon and oxygens by 3 as well. So the simplest whole number ratio we get for carbon, 1 times 3 is 3, and for oxygens also we need to multiply by 3, so we also get 3. Hence, in step number 6, we get the empirical formula for ascorbic acid as C3H4O3. Some of you must be wondering why, when I got 1.34 mole ratio, I need to multiply by 3. It is because 1.33 is approximately equals to 4 over 3. So how to make 4 over 3 a whole number? We can only multiply 4 over 3 by 3 to give you a whole number 4. In fact, when we calculate mole ratio, we get numbers such as 0.333, 1.333, 2.333. We must remember that all those numbers has the denominators equals to 3. To make those numbers whole number, we must multiply by 3. Besides 0.333, if we get 0.667, 1.667, 2.667, and others, we must remember that those also having denominators as 3. So to make them whole number, we also multiply those numbers by 3. How about if we get mole ratio number such as 0.5, 1.5, 2.5, and others? So must remember, if 0.5, the denominators will be 2. So to make those numbers whole number, we need to multiply by 2. Then how about if we get something like 0.02, 1.02, 2.02? So if we get those numbers we can just round them out to the closest whole number. How to determine the molecular formula for ascorbic acid? We need to find n first, the whole number multiple. So how to find whole number multiple n? Molecular weight, so the molar mass, divide with empirical formula weight. So the molar mass of ascorbic acid given is 176 gram per mole, divide with empirical formula weight. So the empirical formula is C3H4O3. So there are 3 carbon, so that's why 3 times 12 gram per mole, because the molar mass of carbon is 12 gram per mole, plus 1 gram per mole times 4, because there are 4 hydrogen and molar mass of hydrogen is 1 gram per mole, plus 3 times 16 gram per mole, 3 because there are 3 oxygen and the molar mass of oxygen is 16 gram per mole. And the whole number multiple n here is 2. So means that the subscript n is 2. By multiply the subscript n2 into the empirical formula, we get the molecular formula for ascorbic acid as C6H8O6.